right, co-requisite material for lesson number 5. I want to review negative exponents since they do come up a little bit in this lesson. So the trick to again in teaching this content, over the years, I've noticed that negative exponents just completely blow some students' minds, and they really shouldn't, because there's a simple trick to addressing these. And the trick is this. If you have a negative exponent, to make it positive, all you have to do is move that term to the other side of the fraction. Now, of course, there's a All right, Coreq material lesson number 5. We're going to begin with negative exponents. Manipulating negative exponents can be a little bit confusing, but I think there's a pretty simple rule. That rule is if a exponent is negative and we have a term, not a term added to something else, but we have just a single term, we can change this exponent to a positive by moving this to the other side of the fraction. Positive exponents are a lot easier to make calculations with than negative exponents. So if I have 10 to the negative 2, which is in the numerator, I can move this to the denominator, make it 10 to the positive 2, and easily evaluate the expression. 8 to the negative 2, I'll tell you what, let me try to make this a little clearer. Hope that helped. So 8 to the negative 2, the 8 to the negative 2 is in the denominator. Move this to the numerator, make the exponent positive. 8 squared is 64. Ignore this, this applies down here. If we have x squared times y to the negative 3 over z to the negative 2, leave your x squared in the numerator. It's already positive, doesn't need to change anything, right? Y to the negative 3, move it to the denominator, make it y cubed. And z to the negative 2, move it to the numerator and make it z squared. Now, that stuff is pretty easy, but we do in lesson number 5 get into more complex expressions when calculating z-scores. And I think one of the most complex expressions that we have in terms of z-score calculations is calculating a z-score for a sample proportion. Now, as you'll find out later, when we have a p-hat, this represents a sample proportion. So this actually came from a sample. So we have 116 out of our 200 total sample, that have some particular characteristic that we're measuring. P equal 0.62, this stands for the population proportion, again, sample proportion, population proportion, and n equal 500 is our sample size. Now, this can be a bit messy, and if we do direct substitution with a fraction, I think this gets extremely messy. Let's just go ahead and write it out just to show you what's happening here. So I have 116 over 200, which is substitute in for p hat, because again, that's the value, minus 0.62, which is the value for p. And then I need the square root of everything, the p times 1 minus p over n, okay? So I have 116 over 200 times 1 minus 116 over 200 over 500. Now, in teaching this class many times, I've seen students do this far too many times. And what they do is they only apply the square root to the numerator. Well, this is just completely wrong. And if you wake up and you just want to get all these problems incorrect, then do that. You're never going to get them right if you approach it that way. Keep in mind that the sample size, this 500, has to be under the radical sign, under the square root. Now, I think you're going to find out that entering this into your calculator is going to be a lot easier if you change your fraction to a decimal. So the first thing that I did is I took 116 divided by 200, and I got 0.58. So every place I saw 116 over 200, I got 0.58. Now, what if it doesn't turn out? Let's say we have 111 divided by 1007, something like this, which doesn't turn out to be a nice number rounded to two places. Well, for technical accuracy, I would round this out to about 5 places. So every place I saw that fraction, I would go 0.110228 maybe, so maybe go out to 6 places, just for technical accuracy. If I just make this 0.1, I'm going to lose a lot of technical accuracy. In fact, I probably won't get the problem right. If I just use 0.11, I probably won't get it right. But if I can go all the way out to like 6 digits, then the technical accuracy of the operations that I use, that rounded answer increases drastically. That's not what we have here. So I changed 0.58 minus 0.62. I put 0.58 there. We probably should all be able in our head to take 1 minus 0.58. If you can't, don't worry about it. You've probably got a lot of talents that I don't have. Doing this in your head just isn't one of them. If you need to do this in your calculator, then do it on your calculator. All right, so 1 minus 0.58, 0.42 over 500. At this step, I think I would probably do these separately in my calculator. So 0.58 minus 0.62. You don't have to. And then I would probably, in the denominator, I would do the square root. 0.58 times 0.42 divided by 500. And again, take this answer out to about 5 or 6 places. I took it out to 6, which gives me some technical accuracy there. So negative 0.04 divided by 0.022073 gives me negative 1.81. Now, complete transparency, this is not the way I would do this problem if I was doing it, but I'm a little better at this than maybe some of you. What I would do here is the following. I would type in 0.58 minus 0.62 divided by the square root of 0.58 times 0.42 divided by 500. I would do everything in one line, okay? And when I do that, I get negative 1.81, just as we did if we broke it up. But again, I'm pretty good at this stuff, and maybe your strengths lie somewhere else. So just know who you are, know what you need, break it down into smaller chunks if you think that's going to increase the probability of you getting the answer correct, or if you feel more comfortable entering things into your calculator, then you may consider this approach. Now, there's not a one approach fits all, because it just depends on your background and your comfort and experience with entering things into your calculator. All right, gang, that's all I got.